Hi, good morning. I'm Alejandro González Escamilla. This is my ID number, and this is the activity 1.2, Electropneumatic circuits. Well, first of all, I researched the standard the FluidSIM program uses, and it uses ISO standard for hydraulic and pneumatic systems is the ISO 1219. However, for some of the components, they also, especially for the electrical, they also use ANSI or NEMA. The first exercise was to do a manual and forward and reverse pneumatic system. It was manual and activated by two push buttons and a double acting that moves a double acting cylinder. And I used two throttle check valves to make the cylinder move a bit slowly. I will start the simulation to one side and to the other one. Throttle check valves work in that way. When pressed, they make the air flow in this direction, but when returning, that is like throttle and don't let that much air pass, but when passing to the other side, they pass to this mechanism that is like a little check ball that sometimes closes and sometimes open. Well, this is the first activity. Some other elements are of course the supply compressor, and that will be it. Then for the circuit with automatic piston return, the simplest way to do it was also with a button and a spring return piston, such as this one. However, I also tried to do the activity by pneumatically operated with this push button. The circuits the the circuit works this way. You activate the push button and move another 5 two-way impulse bulb to one side, and when pressed, the 5 two-way bulb moves to the other side, which makes the double acting cylinder go to the other way. We could also include a throttle check bulb in here, but I decided to not include it. And finally, the last activity was the design and construction proposal that was this image. We have two cylinders and it will be moved completely automated. Cylinder A will advance, then cylinder B advance, retract and retract. And I do it this way. Advance, advance, retract, retract. Advance, advance, retract, retract. I added this switch to turn it on and off. And the way it works is this way. We had to use the use of sensors. However, the sensors of one cylinder activate the other one. When the first thing that happens is cylinder A goes to the other side and activates A2. Then A2 moves the cylinder B to the other side and activates B2. B2 retracts the cylinder in here and activates A1, which makes the cylinder B retract. And check the V1 sensor that activates once more cylinder A, and it continuously undefined. These these bulbs are linked with the which is of the sensors that I indicated here, A2, A1, B2, and B1. And it works that way. Of course, the throttle check valves are also in here to make the piston move a bit slowly. Well, pistons on the industry have many applications, whereas they could work as a gripper, as a mini elevator to move one piece to the other side, etc. And each of these systems could work depending on the specific industry or plant. Maybe sometimes you will need the piston to return automatically to perform a sequence, such as in the third example. It will greatly depend on the application. I think that will be it. Thank you.